All right, guys, so here is a video on how to balance combustion reactions. Now, I'm going to do this a different way. I'm going to show you the tricks. I'm going to show you how I balance combustion reactions and how it works every single time, no matter what. You do not have to do it this way. If you're watching this video and you're like, what the heck is she doing? I have no idea what's going on. Then just forget about it. Delete the video, walk away. Do it however you want. I'm just going to show you guys some tricks that I like. If you know the tricks, you can balance any combustion reaction. I don't care how hard it is. It's going to be super easy, super fast. You just have to follow a couple steps, a couple rules. Just like everything that we do, there's tricks, there's shortcuts. And if you can, if you know those, great. But you don't have to in order to be successful. It's just, if you want to take the time to learn these tricks, well, then it'll make your life a little bit easier. So we're going to start off. My number one rule for combustion reaction is save the oxygens for last. Like literally just don't even pretend they don't even exist. Save those oxygens for last. I've been really going back and forth. This equation that I have here is like the most complicated one, and it has all of the different exceptions to the rules. And I have been going back and forth on whether or not to show you the complicated one first or the easy one first. So we're just going to start with the complicated one, and then that's going to encompass all of the rules. And then we'll do one or two examples, without. So, all right, save the oxygens for last. And actually, just to show you guys how nice the trick is, try to do this one on your own. Go ahead, pause the video, try to balance this and see if it takes you a long time, see if you can get to what you think is the right answer, and then watch the video and see if you think that the pathway that I take makes it easier. And if it does, great, then you can use it, you can practice it and you can use it. And if not, if you're like, I figured it out on my own, I don't really need this, then even better, you're good to go. So I was supposed to write number one here, so let me fix that. Number one, save the oxygens for last. Okay, so I'm going to go ahead and balance my carbons and hydrogens using this blue color. So that, balance carbons and hydrogens. Carbons and hydrogens. So I'm going to look here. I have 3 carbons, so I'm going to put a 3 right here, and I have 7 hydrogens, and I can't really multiply anything by, and actually now I'm realizing that this is going to be a even more special kind of example. But if I see 7, if I see an odd number of hydrogens, there's nothing I can put here times 2 to get 7. It's not possible. So what did I say about odd numbers? Mrs. Cook hates odd numbers, and I want to get rid of them. And what can I do? What can I multiply this here 7 by to make it an even number? What's the best way? Well, you double it. Anything doubled is going to be even. So 7 times 2, now I have 14. So here I can put a 7, and that gives me 14 hydrogens. So my hydrogens and carbons are done. I'm going to move on. Now, the next thing you want to do, you're always going to total up the oxygens on the product side. So I'm going to count. I have 3 here. I'll use red for this. Total up the oxygens on the product side. So I have 3 times 2, which is 6. And I have 7, and that's a 1, so just 7. So 6 plus 7 is 13 oxygens total. 13 oxygens total. Now, normally, I don't even know if I should say this right now. Normally, we would do a step here. But because this is, like I said, a special example, before we do the next step, we're going to do like kind of a sub-step. So how can I write this out? Okay, so the next step is to divide, whoops, why am I not writing here? Divide the oxygens by 2. So this total number here, whatever you get, you divide by 2. But if you see any oxygens in the hydrocarbon, then you should subtract those before you divide by 2. So if you see any O's in the hydrocarbon, subtract before you divide. Okay, so we're going to do this in green. If you see any oxygens in the hydrocarbon, subtract before you divide. So I'm going to go back to my hydrocarbon. I'm going to subtract any oxygens. And I have 2 times 1 is 2. So I'm going to do 13 minus 2. And 13 minus 2 is 11. Yay. So once you've subtracted those oxygens, you divide by 2. Or I'm sorry, subtract those. I said that right. So divide by 2 and then subtract your oxygens. Oh my God. Just stop listening to me, maybe. Subtract the oxygens and then divide by 2. So we'll do that in gray. I subtracted 2 oxygens. Now I'm going to divide by 2. You might be saying, Mrs. Cook, you can't divide 11 by 2. Well, you can. You just get a decimal. So let's just do it because that's what Mrs. Cook said to do. So 11 divided by 2 is 5.5, right? 5.5. Now, after you divide by 2, that's your coefficient for O2. So I'm going to take this 5.5. I'm going to put it right here. 5.5. Now, let's pretend like that's okay. All right, let's just pretend. Is the equation balanced? We know that our hydrogens and carbons are because we did those first. So let's check out our oxygens. 5.5 times 2 is 11, plus 2 is 13. And again, over here, let's count. 6 plus 7 is 13. Yay, it's balanced, but everybody knows that we can't have a decimal coefficient. It has to be a whole number. So what is the best way to make a decimal number a whole number? Again, by multiplying. You multiply by 2. Multiply everything by 2. So this last step here, again, is a sometimes step. If your coefficient is a decimal, then multiply all coefficients by 2. Double everything. Oops, that's not a 2. So I'm just going to go through and double everything. And I need a new color here. Let's do a nice bright pink. So I will have 4 and 11 and 6 and 14. And I know that's my, reduced answer. I can't divide anything by these. 11's a prime number. So that's our final balanced reaction. Now, if you were able to come up with that on yourself without these tricks, then you are good. But I think that these things are definitely going to make it a little more straightforward. Now, you can't just watch this and watch me do this one example and know what you're doing. So I'm going to make another video that just has a couple more examples that are different looking, and but the steps will be the same. So if right now you're looking at it like, I really want to do this, I really want to use this trick, but I just have no idea what just happened, watch the next video and see if that helps. If you watch this and you can follow, literally it's just step 1, step 2, step 3, sometimes step 4, sometimes step 5. But really mainly this one, and this one, those are your 3 steps. Save the oxygens for last, total them up, divide by 2, that's your coefficient. The only time there's an exception is if you have a decimal, coefficient, or if you see any oxygens in the hydrocarbon. Otherwise, it's always going to work 100% of the time, no matter what. All right, so I'll make the next video for those who need it, and then we can go from there.